Hello, this is KGP Today presenting VHDL Basic for the students of Deploy NEC GTU. So we are going for the first slide. The first slide is basically deals with the basic coding of VHDL, how we can start with. So first thing you have to take care about the library, the declaration part, then you have to go for the entity, then architecture. These are the three main things that you have to take consideration into the programming of VHDL whenever we are starting with. So that's why the code is been given basic VHDL code. So this figure is I've taken from the Pedroni. Now we'll go for the declaration part. First you have to write library IEEE, where as we have seen we can something is written there, so semicolon indicates the end of the statement. When you are writing anything, you have to end your statement with a semicolon. So library IEEE, there you are just defining the you are taking care of library IEEE within your program. That's why you chosen that. Then you're using that package that use IEEE dot standard underscore logic underscore 1164 dot all. Then we'll go for the next library standard. So that is also related to the semicolon and the library declaration. Now the next thing is, whenever you are making double dash, the double dash basically indicates a comment that is also written. Now the next part, this is all about the declaration. So you have to declare like this. In the programming, the second part as we see in the block, that is entity. An entity is a list with the specifications of all input and output pins, or it can be also known as ports of the circuit. So whenever you are defining any type of code, then you have to go for the first input output pin so that you can identify within the entity division. So entity, that is one of the important things. So first we have gone for declaration, then entity. So as we can see that one of the example that is written below. Let us consider the NAND gate. Its entity can be specified as entity NAND gate is port, where port is A and B, both are considered as in bit and X as output bit. That means we are considering the 3 pins for the NAND gate, 2 inputs and 1 output. A and B considered as input and X is output. Then we'll go for the next slide, that is regarding architecture. The architecture, that is nothing but the description of how the circuit should behave. So that means the function of the total circuitry that is defined by the architecture. So first part declaration, then we have gone for the entity that will define the pin output, input output functions, and then we'll go for the circuit, how the function of the circuit. So there is one example that is given below, that is NAND gate function. So architecture my arc of NAND gate is first you start with begin. So begin, that is one of the starting example. Then we are assigning A and B to X, where A and B both are input and X, that is one of the output. And whenever you are starting architecture, whenever you are starting with begin, then you have to end this. So name of the architecture is given my arc. So architecture begins as well as it will end. So that's why they have written end my arc. Now this is a sample code. Here we can see that the line from second and third, that is considered as declaration. The line 5, 6, 7 and 8, those are considered as entity. So you are defining input output pins. So the data type you use, that is standard underscore logic. And the next part, the most important, that is architecture. So you are basically behaving how the program behaves. You are writing the function within this span. So that is the line starts from 10 to 20. That basically gives you the sample code, the architecture of the sample code. Now we'll go for the next. Here the declaration. Actually in this particular slide you can see that we are explaining line by line how your program behaves, how your code behaves. So line 2 and 3, the library declaration. So we can see here 2 and 3 both are library declaration. Here 5 and 8, basically 5 to 8 lines are entity definition and architecture behavior 10 to 20. So we can see that. Then next 6, line number 6, that basically defines input ports. So here we can see that the line number 6 basically defines input port. The line 7 basically define output port. 11 to 19, the code for architecture. So 11 to 19 code for the architecture. Here we have defined process. The code apart from the architecture word start from the word begin on. The 12 to 19, here we are defining the process. The process is basically a sequential part, so we'll consider this later. The process is executed every time a signal declared and its sensitivity and less changes. In this example, they use reset and clock. So reset and clock, that is one of the variable that we have used in process. So process basically related to the sequential programming, so that would be considered in the later stages. Now 14 or 15, where every time how it will rotate and how the reset goes from 1 to 0 or 0 to 1. So how they are defining, so that is known as asynchronous reset. Now 16, 17 lines are also related to the clock and the output of the Q. This is the program of if you can see, this is the program of D flip-flop. So they were considered as few flip-flops. The Q, that is output, D that is input, the clock, then event. So many things were there. Later line 15 and 17, here we can see that the symbol that is given, the symbol that is operator, that is of signal. So they are assigning a value. So this is nothing but the assignment. When we are writing this is a signal assignment. In contrast, this symbol is for the variable. All ports are in entity are signals by default. All ports in the entity are signals by default. So we are basically assigning by this symbol. Will not go for this. Okay. So this for variable, this is for signal. Now 1, 4, 9 and 21 commented dash dash, that indicates a comment. Now the note has been written, VHDL is not case sensitive. That means you can write in any case. Now the waveform of D flip-flop, here you can say the I has been written, the reset, D and clock, these three are inputs and one output, this is O. So O, I, they've written, we can see the waveform. So whenever the reset pin is high, clock is there, we are not getting any type of output. But whenever the reset pin goes low, whatever the input of the D, that will be transferred to Q whenever the clock changes or starts from 0 to 1. So and after that the RTL viewer has been shown. The RTL viewer is perfectly done. A and B in AND gate, and then clock, then D flip-flop is considered as input and Q is output. Now the data type, the very important thing. Whenever you are doing any type of programming with the VHDL, then you have to take consideration on data types. Otherwise, it would create many types of problem. Now the first will go for the predefined data type. That means already defined. We are not defining. That is already defined. So we can go for the predefined data types. VHDL contains a series of predefined data types specified through IEEE 106 and IEEE 1164. Actually, in any type of programming of VHDL, basically normally we are using IEEE 1164 package. So on the package is shown below. The package standard of the library standard. Whenever you are using standard library, that defines basically bit, boolean, integer and real data types. So we are using one of them. Next, this package standard underscore logic underscore 1164 of library IEEE basically defines standard underscore logic and standard underscore U logic data types. What is standard underscore logic and what is standard underscore U logic, that will be considered later on. Next, the package we can go for, that is standard underscore logic underscore arith of library IEEE. Here we can go for the arithmetic operations. So some of the rhymes will get the values in terms of signed or unsigned integers or data types. Several data conversion functions may be there. So we can use this type of the example in standard underscore logic underscore arith. So this is basically related with the arithmetic operation. Next package we can go for, if we want to go for the separately for the standard underscore logic sign and unsigned for the library. It contains a standard underscore logic vector data perform for the if the data were of type sign or unsigned respectively. Now predefined data types. We can go for a few examples of the predefined data types, where we can first go for a bit, where bit can be considered as two logic level. Either it can be 0 or it can be 1. The example of that, signal X is equal to bit. That means we are defining X as a bit, and that is also considered as signal. That is a 1-digit signal of type bit. Next, we can go for a bit vector. So signal y considered as bit underscore vector 3 down to 0. So y is a 4-bit vector because we are starting from 3 and down to 0. So 3 2 1 0. Okay, and 4-bit vector with the leftmost bit being the MSB. If we are writing 0 to 3, then rightmost bit would be the MSB. Here we are writing 3 down to 0. That means the leftmost bit being MSB. That is one of the very important thing that we have to take consideration. Next, the signal W is a bit vector, bit underscore vector is 0 to 7. That means the W is a 8-bit vector with the rightmost bit being the MSB. So whenever you are writing the leftmost, then you have to write down to, and if you are writing the rightmost, then no need to write that down to. You can write directly 0 to 7. Next is X. We are assigning value 1 to X, that is of 1-bit value. So X is a single bit signal whose value already we have defined the bit as X is a bit of single bit. So here we are defining 1. We are assigning 1 to X. So X is a single bit signal whose value is single quoted 1. Notice that the single quote is used for the single bit. So whenever you are having more than one bit, then you have to define in within the double quotes. So next example, y is y we have assigned 0 1 1 1 to the value of y. So y is a 4-bit signal whose value is 0 1 1 1, that is quoted within double quotes. On MSB is and MSB is 0. Notice that double quotes are used for the vectors. So whenever you are using double quotes, then you have to first define that particular thing as a vector. So we have defined already in the above signal y is bit vector. So that's why we have defined this within double quotes. Again we can go for the W. So here again we have defined this W as a bit vector. So we should define this within the double quotes, and MSB would be 1. That is from right hand side. So that's why the rightmost bit MSB is 1. So that is little bit 0 to 7. Now we'll go for the standard logic, or we can go for standard underscore logic underscore vector 8-value logic system. Why we are using standard underscore logic? Because within the IEEE 1164 standard we are using standard underscore logic. That means we are having 8-value logic systems. So we can go for the first one, that is written capital X, that is known as forcing unknown. Same as we can have 0 for forcing low, 1 for forcing high, Z for high impedance, W that is for weak unknown, L that is for weak low, H weak high, and dash that is for don't care. So if we are having standard logic, that means we can follow this type of 8-value logic system. That means whenever you are defining standard logic, any of the 8 signals may be given to a particular the definition to the particular signal X, Y, A, B, or whatever it may be. So signal X, the next example we can go for signal X, that is standard underscore logic data type. That means X can be defined of any one of above 8. So that is one of the 1-digit value, and that is known as scalar. Whenever you are having one of the more than 1-digit value, then it may be known as vector, and whenever having only 1-digit value, that is known as scalar. Now signal Y, that is defined as standard underscore logic underscore vector, that is 3 down to 0. Again we are defining this as a variable, or and that is the starting value, or it can also be known as initial value, that is defined within the double quotes. So 0 0 0 1. So we can write we can see there Y is declared as a 4-bit vector with leftmost bit being the MSB. The initial value of the Y is 0 0 0 1. So we can notice that the particular symbol operator that is used to establish the initial value. Now the next is little bit extension of the standard underscore logic, that is standard underscore U logic, or it can be also considered as vector. Standard underscore U logic underscore vector, that is nothing but 9-level logic system. So one of the extra logic system has been added, that is capital U, that is used for the unresolved. So IEEE 1164 standard also defines standard underscore U logic having 9-level logic system. Now we can go for the few more data types. So first one we can go for Boolean. So the it may be considered as true or false. Integer, The 32-bit integer starts from the value that is returned. The natural non-negative numbers, then we can go for real, the physical literals, character literals, and sign and unsigned things. So these are the things